All right, everyone. Welcome to Energy Part 2, Potential. Now, this is the second part of my energy series. This is about potential energy. Specifically, potential energy is stored energy. Now, this is energy in things that aren't yet moving, so it's not in kinetic, and it's when things have the ability to do something, they're just not doing it yet. Now, we actually have 4 types, but we're not really going to talk about all of them, but let's go through them anyways. So our 4 types of potential energy, one is the most common, and that's gravitational. So this is the potential energy exerted by gravity. If I'm holding an object above the surface of the Earth and the Earth is pulling on that object will have gravitational potential energy, because if I let go, that potential energy will turn into kinetic energy as it falls to the ground. The second one is chemical potential energy. When I take a match and I hold it, before it's lit, those bonds in those atoms in the compounds are ready to break and be reformed, releasing heat and light in the form of fire when I strike the match. That is chemical potential energy. 3, we have spring energy, spring potential. So when we take a spring and we hold it or stretch it apart, it wants to come back. Or if we compress a spring and it wants to open back up, that is spring potential energy. And lastly, we have nuclear. Nuclear potential energy is similar to chemical potential energy, but instead of looking at the energy in the bonds, we're looking at the energy in the nucleus of the atom, ready to break and explode and release a whole bunch of energy. You may think about this when you think about atomic bombs, because, well, that's the kind of energy that was there. Now, the one we're going to focus on today is gravitational potential energy. It's one of the most common ones you find. So gravitational potential energy is, again, the potential energy exerted through gravity. So, for example, we generally have an equation for it. Just like with KE, we had KE equals 1/2 mv squared. For PE, for potential energy, we have mass times acceleration due to gravity. So I'll just say, right, gravity times the height above the surface that we're doing it. So we may simplify this to mgh. Now, once again, I'm going to be very specific about the units. Mass is going to be measured in kilograms. Gravitational acceleration, which is acceleration due to gravity, is meters per second squared. And height is going to be meters. So these are our units. Now, it's very important to keep this consistent. And this is what we're going to use for any object above Earth. Now, one quick thing is that this middle one is always constant, at least constant for objects near Earth. And by near Earth, I mean like on Earth. Let's just change, let's say on/near Earth. So even planes will feel this. And this is going to be about 9.8 meters per second squared. Sometimes you'll abbreviate it to about 10 meters per second squared if you're lazy and you're trying to make your math easy. But it's about 9.8 meters per second squared. So without further ado, let's just go ahead and jump into an example. So a quick example might be that we have a bowling ball with a mass of 5 kilograms, 5.0 kilograms, and we hold it 2 meters above the ground. Pretty simple. what is the potential energy? So we're just going to go ahead and say potential energy is equal to mgh. And let's go ahead and highlight what we've got. We have 5 kilograms. We have 2 meters. So we definitely have right here our mass and our height. Our gravity is once again going to be 9.8 meters per second squared. So with this, we can go ahead and solve. Potential energy is equal to 5 kilograms, 5.0, times 9.8 meters per second squared times 2 meters. So once we go ahead and do this, turns out our potential energy is equal to 98 joules. And all I did was multiply 5 times 9.8 times 2, and we get 98 joules. That's it. That's all there really is for potential energy. And if you have any questions, let me know. Otherwise, have a great night.